deserve that much praise, but this is just really just a good opportunity to thank everybody for putting this together. And I think it's going to be a great discussion that we'll have today. So I think I'll stand if that's all right.
Just another mic there.
Okay, great. Thank you. Let's hope this works. Incredible. Okay, so hopefully you guys can hear me. So as Juliano was saying, because there'll be slides, so maybe it'll actually make sense. Someone can cut me off as well, but so as Juliano said, my name is Umang Bhatt. I am an assistant professor and faculty fellow at the Center for Data Science at NYU. I've recently just completed my PhD at the University of Cambridge, which is actually still where I was when I met Juliano. But now we're back in America. So I'll jump right into it. The point of today's talk will be to give you a sense of what a computer scientist thinks about how to regulate AI-assisted decision-making. And instead of having a set of prescriptions, I want to introduce you to a relatively new idea that we've been thinking about. And we can take it from there, and I think we'll have a discussion thereafter. So, as Juliano mentioned, the title of today's talk is AI-assisted decision-making. And I don't think this is a good title for the talk, actually. A better title is probably, if this clicks, self-regulating AI-assisted decision-making, right? Is there a way for us to automatically regulate AI-assisted decisions? Well, that's pretty difficult. It already is difficult to regulate an automated decision-making system. So the question that I'm going to pose to you is the following. When should algorithms resign? Okay. The whole point of today's lecture will be centered around this idea of resignation. How do you resign an algorithm in favor of human judgment? And then how can a room of abogados like you guys end up going about regulating that, right? Especially if there are mechanisms internally in the AI systems that let you resign. I like to start most of my talks zoomed out entirely. I don't think the animations are going to work. So you're going to see a lot of stuff at once, so I'm going to apologize for that in advance. But generally, I like to start my talks off by putting up this kind of figure where when we're considering machine learning models and assisted decision-making, on one hand, you have a model, and on the other hand, you have some sort of stakeholder, okay? And there are a bunch of interactions that we try to have between these two agents. And for all intents and purposes of this line of research, it's called human-machine teams, okay? It is a combination of human-computer interaction, artificial intelligence, computer science, and a lot of the other humanities as well. When we start to think more deeply about this human-machine team, we can start to think about, well, what are the different types of tools that live on this side, right? On one hand, something like ChatGPT, something like Netflix, Autopilot in Tesla, Siri, they're all different types of models that we interact with. If I'm an engineer, I'm interacting with it. I might change a line of code in Netflix so that some new film comes higher up in my rankings. I might be an executive, someone who's actually has a vested interest in machine learning. Regulators, end users, and you and I as well, right? Everybody has a vested interest in AI systems, but we interact with a lot of them. And some of them some of them up here, you don't even think of as AI systems in some sense. We don't think anymore of Facebook's recommender system as an algorithmic system, but for all intents and purposes of this discussion, it will be. And the questions that you'll start to ask is, well, when you're interacting with these systems, when do you start to rely on them? Because there's no such thing as assisted decision-making if there isn't a precise discussion around reliance. So generally, I'll walk through this slide, so bear with me. As an individual, when you're viewing a machine learning model prediction or getting a recommendation from Netflix, you have many options on how you use that recommendation. No one is telling you to always adhere to it. No one is telling you to never adhere to it. So we did some work a few years ago to characterize this relationship, where we can say, well, you might decide to align every single decision you have with the algorithmic system. This means that someone like Carolina will just take what Netflix says and watch every recommended movie on Netflix. Okay? So we call this the notion of loafing. For those who've taken organizational behavior, this might be familiar as the idea of like social loafing, where you're a complete subordinate to someone who's more senior to you. So you can think about this idea of always using autopilot to take to off-ramp off of a highway as loafing. If you're always going to use it and always going to adhere to it, you're in the state of loafing. On the other end of the spectrum, theoretically, there's another point that with some philosophers, we came up with called opposition. I call this theoretical because in some sense you have to be consciously going against what the algorithm tells you every time, which is actually rather difficult, right? If you want to watch one TV show, you literally cannot watch any YouTube recommended movie, or video. So in some sense, for our study of assisted decision-making, we need to characterize this, right? We need to characterize, on one hand, you align everything with what the algorithm told you. On the other hand, you align nothing with what the algorithm told you, right? And what ends up happening is that we can have two initial states that appear in the middle. One is known in the community as appreciation. This is also known as overtrust. The idea is that a majority of your decisions are going to be kind of aligned with what the system told you. So this means maybe every single day, but Fridays, you adhere to what the model told you, right? And all the other days you decide to either not engage with YouTube, for example, or you have a different mechanism you use as opposed to the recommended videos. Okay? This has been studied in various fun contexts where you can actually get people to over-appreciate, right? That's why it's also known as over-trust. In some sense, you're using the system more often than you should. For those who are precise, and you might realize that it's probably easy to realize opposition and loafing. When you get into this middle ground, it's much more difficult, right? I mean, these are theoretical gray spaces. But by putting language on this, we can start thinking about how we even start regulating decisions in this space. So on the other hand, there's this notion of algorithm aversion where you might align a few decisions with the model. This means that you might only use the system when you really, really need it. And then this is the setting that I generally fall into, right? I usually know what I want to watch on Netflix, and I might sometimes end up using it to help me. And that sometimes might be less so than I need to, right? I mean, sometimes I'll end up watching pretty trashy TV. And that is, in some sense, an implicit display of what's known as distrust. Right? I want to be different from the average user. Therefore, I might actually decide to change my relationship with the tool. And the reason in this work that we published a few years ago, we'd actually coined a term that's this optimal point. We want to be vigilant. This means that when I use the system when I want to and when I should, and I don't use it when I don't want to. Okay? It's great in theory. But in practice, it's obviously very hard to realize this. But I hope this starts to give a language to think about the headspace that I'm coming at this problem from. As someone who builds machine learning models, the number one question is not necessarily did you get the prediction right, but when did you listen to me? And if I can characterize when you listen to me, then we can do a better job of starting this regulation discussion. Right? So in some sense, we can walk through and place some headlines that have been in the news on this scale, on what types of reliance people have displayed. So there was a judge that was recently sanctioned for having a ChatGPT use basically generated fake citations, and that was in a ruling. This happened again here in Brazil. You can kind of think about this as an overappreciation, right? It's somewhere in that gray space. I didn't use it to write the whole brief, but the parts that I did write were not good and I didn't edit them. Right? I wasn't vigilant in some sense, right? Tesla had this amazing it's horrible, but it's a quite wonderful autopilot crash case where when the autopilot turned off, it is no longer the fault of the algorithm developers, okay? So naturally, we are actually starting to regulate and litigate across the spectrum, okay? Without being precise. And that's why I've introduced this spectrum. So we can start thinking about, okay, well, the only reason how will we regulate in the case where someone is loafing when you're not actually implicitly using your own intellect, expertise, or experiences to make decisions. A great deal of other examples. There's a bunch of health insurance, CVS, a health insurance company in America. They've actually been working on using AI to deny services, but the problem is it disproportionately impacts some groups. So this brings up very important questions around fairness and things of that nature. Same thing with when you're trying to predict who to arrest. When you're doing this, you might end up disproportionately targeting one group of people. There was a woman who was arrested even when she was pregnant, which I think the fact that she was pregnant is definitely relevant, but the fact that the system got it wrong and the cop made a decision actively appreciating the algorithm's work, it leads to not only bad press, but also to just a bunch of downstream errors. And a similar thing that happens with in the pharmaceutical industry. Right? So we're starting to see, I mean, you guys can all think of lots of cases that would fall along this boundary of what type of reliance did the individual who is using the AI system have on the system. We can place it somewhere along here. Now, the thing that our research tries to do is kind of think about, well, what type of relationship can we actually even have between the model and the stakeholder? And what I want to argue for today is the notion of appropriate access. Okay? Can we make sure you have access to the tool when you need it? And then you do something about it. Right? So this will be the crux of today's discussion. The way we like to think about it is that, can we add what I'm calling a veil of selectivity, right, where the stakeholder can see the model sometimes as some function of how good the model is and how good the stakeholder is at making the decision. Okay? So you get access to the model based on how good you are, how good the model is. Now, in theory, this is a great idea. In practice, it obviously gets pretty difficult. But the premise for avoiding a lot of the errors that we were just talked about will be this, right? How do we selectively design systems to basically consider the fact that they're not very good? So you might want to redesign them in favor of human judgment, which we do know how to litigate, right? To some extent. I mean, maybe there are issues with overblown courts and courts having too many cases to review and things of that nature, but definitely something worth thinking through. So the outline of the remainder of the talk will be the following. I'm going to define what's called algorithmic resignation, which I've just briefly talked about. We'll talk about the benefits and considerations of it, and then I'll run you through a set of examples that kind of discuss this. So what do I even mean by algorithmic resignation? So algorithmic resignation is the deliberate and informed disengagement from AI assistance in certain scenarios. Okay? There's two key operative words there. The deliberate and informed disengagement. Okay? This means that we're not just turning it off randomly without telling you. We're going to inform you that I'm turning off this system for some reason, and therefore you're going to kind of be on your own. Okay? And we think that this is an important direction for people to start thinking about from a legal perspective, because more and more often we're going to see this happen, where systems start to resign at the right moment, and then it'll always still refer back to human judgment. So it might be in an organization's best interest to start implementing algorithmic resignation. So let's give you some examples to put some meat to the bone. And I apologize that they're not coming in as animations, because I know this could be a lot. So suppose I'm a hospital. I have two different doctors. Okay, Alice is a senior doctor and Bob is a junior doctor. One option is that I might have a diagnostic predictive system that I give my senior doctor full access to. They're an expert. They know that when they need support, they might not loaf. So it might make sense for us to give Alice full access to the machine learning model's predictions, because we don't expect them to use it often. Whereas Bob is a junior doctor, not very good, still in training. It might make sense to give partial access. Right? So what we'll do is we'll give deliberate and informed disengagement from the AI system to Bob. We'll tell Bob, well, actually, this system's not for you. Okay? And what this will permit us to do is it'll help us mitigate those errors and risks that we saw downstream. So we'll walk through a couple examples of these. Another one would be, for example, in the same hospital, let's say Alice is a doctor, now Bob is a nurse. Well, maybe Alice gets access, but with a disclaimer saying that this model isn't very good or hasn't been certified yet. There's a bunch of certification work that's happening across the US and the UK at the moment. But actually, Bob doesn't get access at all. Bob doesn't have clearance in some sense to have access to this system. And what we're actually arguing for, which I know I've written out here on the stakeholder perspective, is actually you can bake this orange part into the AI system. That's a lot of our technical research, actually. Our technical research can actually automatically build a filter to make sure that the person who's seeing this system actually deserves access to it. And what this does is it opens up a whole new avenue of thinking about how we regulate these things, right? Because we'll talk about it a little bit later, but as a teaser, like the idea of an AI system being banned from usage the way the EU is doing. They're saying that, look, these are use cases, biometric inference, something to do with social scoring and things of that nature. Well, those are off limits. So that's doing it on the use case level. Here, I'm actually saying at inference time, the system is actually using that same logic, just applied down to the more technical level. Oops. All right. Oh, great. So there are lots of reasons how we could go about thinking about appropriate access. One might be there's cost benefit, right? If I'm a hospital and I own ChatGPT and I have a license for that, I don't want to give everybody access to it. I would want to give it to a select number of people. So there's cost benefits, expertise benefits, like we said for Alice and Bob. Now, interestingly, for this group, there are internal policy and external regulation reasons. Like we might have policies internally in place that we want to adhere to. So this might be a usage policy for when ChatGPT ought to be used. It's not something that's coming from the Department of Education yet, but it is coming from the school district, as it were, right? So you can see, I hope, start to see this idea of like how I'm thinking about this problem of access. And now we'll get into some of the benefits. But before we do that, one of the things to think about is I think it's important to recognize that this goes a little bit further beyond the disuse of systems. This is not just saying that don't use them. It's really saying embed this governance mechanism into the AI system itself, right? Where now it's not just up to the other individuals to litigate them. It's actually the AI systems have governance embedded within them. Thus the second title, self-regulate, right? Where you kind of have embedded this governance directly into these systems so that people are guided on when they should use them and how they should use them, right? So one of the things that we can now start doing is like, well, let me walk you through some of the benefits of these kinds of systems. Like what would be beneficial about them? So the first thing, and apologies, they're gonna all come up at once, but the first one is actually economic efficiency. You can save a lot of money by doing this from an organization's perspective, because you have a good sense of who's using what system and when. You can think about it like implementing a set of credits that someone has access to these kinds of systems, where now the best part is when it comes to governing these systems and regulating them, you actually can just govern the credits. You don't need to govern what the AI system does in some sense because it is an assisted decision. There are obviously interesting reputational gains. So I imagine everybody in this room has used something like Alexa or Siri, Google Home. When queries fall short, what ends up happening is that the queries, you might hear the following, which is, I don't know what you're saying, but let me search the web. Effectively, the system is resigning and going to Google instead, right? So there are already interesting reputational things that happen when you start to think about, well, when do you decide to actually provide an answer versus not? And this kind of language can actually provide people with basically a new framing for these kinds of problems. And the last one is an interesting legal compliance question. You can actually start imposing legal compliance directly into these AI systems by saying, do use it in this case, don't use it in this case. But that's not baked in as a post hoc thing that goes through CISO for those who work at corporate councils. Doesn't go through the compliance office. It goes through the actual technical teams now. This connects a lot to the notion of the theory of the firm, the idea that that we can now align our incentives with that of the organization and basically get my employees in line by basically providing a tool like resignation. When we started writing this work, we were thinking about it from the perspective of an organization, just for context, which I hope is clear. This is, why would a Fortune 500 company decide to use a tool like this? Well, here are some great reasons why you would want to do that. Okay. There are also some interesting considerations. I think the one interesting idea that I'm going to pose is the idea of the directionality of when you resign matters. So on one hand, I've discussed resignation as the idea of turning the system off, but there also is a setting where I'm a really bad doctor and that I need to be told to use the system. So the directionality can actually be controlled very nicely, but that opens up a huge can of worms because you can obviously quickly get to the over-alliance setting by forcing someone to see these systems. There's an interesting question about stakeholder incentives as well. If we started to do this kind of resignation procedure, hospitals will want to increase the number of EKG scans and insurers will want to decrease them. And these are fascinating questions that are all about the selective use of these tools, right? It's about when do you decide to resign and when do you not. And the last is the level of engagement. So even if I do provide you with a tool, there is no guarantee that you're going to adhere to it. And in that setting, if you did not adhere to it, how do we litigate that? And I don't have a good answer for that yet, right? But if you didn't have adherence, so if I told you that you needed to go watch this film, but you didn't watch that film, or if I gave you very graphic content that might contain illicit behavior and you didn't watch it, whose fault is it? Is it still the person who provided? Is it the provider's fault? Is it the algorithm procurer's fault? Is it the individual? In what settings does that level of engagement matter? So to close, because I know we might be hitting up on time, I'll just want to walk through some examples of what do I mean by resignation. And hopefully this gets us thinking about having a precise discussion about this selective use, because I think the future of AI is not necessarily going to be dictated by how good these systems are. I think that we've almost all ourselves resigned to. They will be excellent, but it'll actually be, when do we decide to actually use them? Right? And that's the question that we're kind of grappling with right now. And if we start grappling with that from the get-go, then we can start regulating them accordingly. So that's one of the reasons why I'm discussing this in the room of lawyers, right? I'm really thinking about this because I think this problem is one that together we can design these nice veils of selectivity that'll live on top, live in the AI system, but be natural governance mechanisms, right? And starting to be explicit about that would be important from the get-go. So I generally like to walk through this, but 3 good reasons I feel, and I'd love to hear everybody's thoughts. One is that this is a new mechanism for self-regulating. So corporate compliance can kind of establish policies to regulate AI systems, and I can bake those right in very naturally. So for those who are representing counsel of firms, it's a very natural thing to do. Just bake in the use of these systems directly into them, into the system itself. The other one is it interestingly orchestrates human-machine collaboration to improve the outcomes and processes, right? So if I wanted to make a more performant system, I don't want to show the doctors that are at my hospital or the employees of my firm incorrect predictions. I want to hide them from that, shield them from that. And this lets you do that very naturally, right? So for example, if you're an AI-powered content moderation tool, you might only escalate content sometimes to human users. You might be able to filter a lot of it out by yourself, right? But it's resigning it for the average case there, right? I'm thinking about resignation as actually, you don't need to use it to filter out things that are obviously illicit. And I think that's an interesting framing of this. And the last one is it actually warrants some clever interpretation of GDPR's automated processing, because AI will be invoked selectively. And what do I mean by this? Because we're not going to be using AI all the time, now what is automated processing, right? It changes the definition entirely. I'm not actually, I might be solely influenced by it at times, but if I'm only using it once a week on February 29th, like once a year, I don't know, like, does that really work, right? So the question is that you can actually start to, agree that AI was not used because it was resigned in favor of human judgment, right? So this is a natural argument for counsel to present, which could be quite fun for those lawyers in the room. So let's walk through some examples now. So for example, let's assume that you had a law firm, and let's say there are 2 individuals in the law firm. They're paralegals and associates. One thing we can do is we can give everybody full access or no access to ChatGPT, right? One option is that internally in communications between the paralegal and associate, it doesn't really matter if they're using ChatGPT to write emails to each other in some sense. But what might matter is that information that the associate sending to their client will be considered legal advice. And because it's considered legal advice, you might want to limit your exposure and basically provide no access or mandate that there's no access for client emails from associates and from anybody who's basically a lawyer at the firm. But for your paralegals, it doesn't necessarily matter, right? That's not necessarily illegal. There's no exposure risk that you have there. So this is an interesting setting where you've resigned in favor of human judgment just for associates, but maybe for other individuals at your organization, they're kind of free for all. Another example, in the medical community, if I am let's say I procured a decision support system from America, okay? I was a Brazilian doctor. I could get partial access to this all the time because I don't know if it's going to work on all of my patients, but an American doctor will get access to it all the time. And this, in the machine learning community, it might sound ridiculous that I'm talking about porting over AI systems from country to country, but this is kind of exactly what we do. We call this transfer learning, where we might not even learn on the local data, but we might just take a model out of box, take it to a new country and deploy it. And what this argues for, resignation argues for, is stopping that. And instead of stopping it at a governance level, because we haven't had much success with that, we'll just stop it by have the AI system stop itself, right? So another example, probably my final one, will be one around a hospital. Again, if I have a senior doctor and a junior doctor and I wanted to optimize for cost, well, I could give senior doctor full access to the system because they're going to use it like a reference. But what I'll do for the junior doctor is I'll give them frictioned access, which will be something along the lines of, are you sure I want to see this? And asking this question, you'll be surprised. We've run experiments on this. It changes the game. It changes your reliance on the system, which then means it's changing the way we'll regulate that decision, right? Because now you can just self-regulate by basically controlling the fact that I'm giving myself selective access to the system. So the last one I'll actually close with is that we've done a good deal of work in this. If you're a school and you had two different types of students, a STEM student and an art student, you might actually give the STEM student access to ChatGPT for arts, and you'll give the art student access for STEM questions. And why would you do something? Well, different students have different levels of support that they need. And that access can actually be learned. So the technical portion, which I've completely removed from here, and if you're interested in this, we can totally talk about this. We can actually learn those orange and yellow arrows efficiently and fast. So I can figure out within 10 to 30 interactions when you need ChatGPT to answer certain questions, just using this notion of resignation. So if I asked you math questions, computer science questions, biology questions, and US foreign policy questions, imagine a lot of folks in this room might need help with US foreign policy. The other ones might be just simple high school level questions. You can answer those pretty easily. So you might need to rely on ChatGPT for US foreign policy, but I don't necessarily need you to rely on it all the time. So it's a cost-saving mechanism for me to learn that efficiently. And this all goes to show that we can basically learn that access to this form of support over a series of interactions, and it complements your expertise, right? You're already very good at elementary level math problems, but advanced US foreign policy questions or advanced computer science questions might require access to ChatGPT to solve. And the idea is that we've built this resignation mechanism that tells you you only really need the system in A and B scenarios, will resign in C and D scenarios in favor of human expertise. So I leave you with the following question: when should algorithms resign? This becomes like the crux of our discussion around regulating systems, because they're starting to think about how are people relying on these systems in the first place? When are they relying on them? And with that, I want to thank all my collaborators, some lawyers, some designers, some engineers. And if you have any questions, I'm looking forward to our discussion. I'm available on all social media. There's my email as well, but I'm sure we'll have a wonderful discussion. So thank you very much for your time.
Thank you very much for your talk, Umang. Really inspiring and interesting. Bernardo, is it possible to show Renata? Okay, so hi. So please meet Renata Wassermann. She's a professor of computer science at the Mathematics Institute at the University of São Paulo. Yeah. She was always there, yeah. And I asked her to start with the debate, but she asked me back to start with the debate. So I will move forward. And I just a first comment. It's really interesting how this is a hybrid subject, that it's interdisciplinary. It needs two different hands, from the computer science and the lawyer. And your presentation already showed it. Because we are talking about here, when you discuss the how and when should machines resign, we are talking about the governance to control or mitigate risks of error. And there are two ways that you may approach it. There is the normative way, which is the regulation, and by ascribing responsibilities for the error to the user or to the operator or to the developer, will bring incentives for the designers to the term when are you going to resign to avoid responsibility. So if we move one piece here of the puzzle, it will affect how you are going to react and design the machine. And the other way around holds too. If you design in a way such that there is a resignation at some point, then this will affect how the lawyer is going to interpret when someone should have acted. If this one has omitted an action that should have been done because of the expected moment of resignation. So if you move your piece there of the puzzle, you're going to affect the piece. So it's a very good idea if computer science sit together with lawyers and try to design something that is reasonable instead of making this game of mice against the cat and vice versa. So this is an important point that you will have naturally brought forward. And I was taken by several questions that came to my mind. I think that I'm going to put them, not everything together. I will wait for the discussion. But one thing that came to my mind is, well, within this game, from the design to the regulation and the ascription of responsibilities, the key point is transparency, because it's from the transparency instructions, from the information that the agents have about the workings of the systems and about the moment of resignation that you find the key for the ascription of responsibility. So within this game, transparency is key. And when we talk about transparency, transparency is a relational concept. Transparency is about giving adequate information, is someone giving adequate information to somebody else. So it depends on who is the object of this information. To whom are you going to inform? Because it determines what is going to be informed and why are you informing. So you have this example, and if you take, for instance, the Institute of Electric Engineers, they have a model of transparency, and they also define different kinds of user that I find interesting. They have a distinction between the specialist user, which is a user who has knowledge of the domain of application. There is the super user who has knowledge of the technical aspects of the machine. So, and there is the normal user that doesn't play any role in the operation at all, but he's subject to the effects of the decision. So, what kind of information we give to whom? And the moment of resignation and the criteria of resignation is also important, because it depends on who are you giving the information. So this is key. Another point which is key that came to my mind is what the system is designed for. Because if there are systems that are designed to be are designed to stimulate overtrust. For instance, autonomous vehicles. It doesn't make sense to have autonomous vehicles if the passengers has to be drivers all the time or have to be vigilant all the time. But regarding recommendations, consumer or product recommendation, then you should be distrusted, because the main drive of interest is commercial. So this is one aspect of I'm thinking about a matrix here. This is one of the aspects, what the system is designed for. The other is, what is the interlocutor? What is the one who is interacting with the system? What sort of information he should have or she should have? And the other key element is the severity of the risk which is involved. So I think that when you were talking, it came to my mind three very complex aspects of this matrix. So I think that given that the game is interactive, so every decision about resignation should consider these aspects and how not only information about the system. It is key to have information about the resignation also, because it's exactly the moment when we take control of the machine. But I think that what is most interesting is that we are always thinking about rules or criteria regarding when the human is going to move and decide to take control, and now it's the other way around. When the machine is going to take this decision. It was really nice and inspiring.
That was a incredibly I don't know if I'm allowed to respond, but that was an incredibly good summary of some wonderful considerations to have. The interesting thing is that the way we actually got into this work is actually via transparency. So my whole PhD is actually all about algorithmic transparency and how different people have different levels of transparency, because I might not need to explain to you how this autonomous vehicle works in great detail, but if you are a specialist or if you're someone who's eventually going to who needs that information, then obviously I need to have that available. But it's not something that's outright given to you just as you arrive. And that's what was happening in the explainability and interpretability literature in the computer science community, where people were just getting explanations for why models are behaving in the way they're behaving, which then reinforces this notion that I need to use this recommender system to buy my next thing on Amazon. Like that's like the explanations and transparency was used as a mechanism to not resignate. It was to go in the opposite direction. But lots of good points. I want to make sure that everybody else gets a chance. Yeah.
Let me just complement what Juliano was saying. For me, I mean, I'm a civil lawyer, so for me, the question of liability is also very important. So knowing who the stakeholder is of utmost importance, you know. So if you have a system, for example, working for the doctors, as you mentioned, for me, it's very important to know who the system serves. Are we talking about a hospital? Are we talking about a clinic? What's the role that the doctor plays in this whole issue of trusting the system or not? When should he resign? And you know, this is for me the levels of liability. For me, it's very important, and then it has everything to do with transparency and the moment of resignation and levels of information that you present to each stakeholder. So that's it. That's the point.
Renata?
Let's see. Can you hear me? Can you hear me?
I think it's too low, Renata.
Let's see here. Better?
Tem como aumentar?
Tô tentando. Melhor?
Now it's better.
Okay.
It's better now.
So thanks, Umang, for the nice talk, interesting talk. I really like the idea of algorithm resignation, and I was all the time waiting for the answer to the question you posed in the last slide. So when should they resignate? Because this is the key point there. I passed the word to Juliano first, and then I regret because he had. So I had in mind the same example of the autonomous vehicle. And when you talked about algorithm resignation, the first scene that came to my mind was So the human driver is asleep in the car, the autopilot is running the car. Suddenly someone crosses the street in front of the car and the algorithm says, I resign. And, now you're in charge. And I think it's very hard to answer this question when we should resign, when the algorithm should resign. I was thinking all the time, who are the people who should decide when the algorithm has to resign? I'm not seeing you anymore, so I hope I'm still with you.
It's green.
Okay. I'm like, oh, disappeared. So I was thinking about who decides, also because you can take so many things into account. And I was just looking again at the moral machine side, because I always use that in my classes about, okay, you have these moral dilemmas that have been studied in philosophy for so many years. And it's not that you have an answer that you can just code into. So as a computer scientist, we think, okay, once you know the rule, you can code it into the algorithm. But if there is no rule, who is going to decide the rule, and how are we going to add this to a system? And then one thing that I've been looking a lot is that people really need to get some education on AI. So then I'm talking about the non-technical people, because we are interacting with things. And especially when we talk about ChatGPT and other language models, what comes out of it sounds so real that people tend to, I'd say, maybe anthropomorphize the system and give it human qualities. And this is the point when usually things start getting wrong, when people forget that this is an algorithm that's running on data that has been trained, and that is not really taking decisions the way we do. So I don't know, not very technical comment, but yeah, I'm really curious about whether you have any idea of who will decide when the algorithm has to resign before we can make these algorithms.
The very algorithm. Yeah, to make the exact algorithm. The algorithm could decide. I mean, that's the point. But no, this is a very good point. And actually, that's one of the reasons why we decided to frame this as something for organizations. So if I am a corporation, it's in my best interest. Where it's like, what is that bottom line? It's profit. And it's saying, okay, well, there are inefficiencies that are introduced by these kinds of over-reliance mechanisms within your employees. And you can very quickly start to control that with a resignation style tool, making sure that employees might not necessarily use them when they don't need to, or you're also caught being efficient in your use of these tools. So that is my starting point. I don't like it. I'm not going to deny that. I don't think it's the best one, but I think it is a good case study for thinking about people who are going to always be at the forefront of AI-assisted decision-making. And I think that's definitely worth thinking about. I really like your point on anthropomorphication here. Like, we anthropomorphize these things all the time. And I think it actually comes down to the way in which we display this information, the way in which we are transparent. So one of the running jokes that has been circulating amongst the tech community is that once ChatGPT and OpenAI got into a partnership with Microsoft, does that mean that Microsoft Word's Clippy, which used to be a little suggestion box, will now be ChatGPT?
right? And if that is the case, then the relationship with it will likely differ, because now I can have you using it without the Clippy and with the Clippy, and we will find completely different levels of non-editing from ChatGPT. Actually, likely that's like what my hypothesis would be. You'd not edit the prose that you get out, and I think that becomes a problem. So at that level, it is up to like a corporation or an organization. Ideally, it would be in regulation, but I think that's too much at the moment. But really, it's like, I have a bunch of individuals in my organization. When should you decide to let people use them and use these tools based on whatever I want to optimize for, which again is a really tough question. So I've answered your tough question with another tough question, which is find an organization and tell me what they want. And given that, we can figure out a resignation policy accordingly.
Yeah. Oh, I'll jump in here. I think, of course, it is the organization who is deploying that is going to make this decision about the resignation. But then if the organization, if there are no standards regarding responsible AI, the organization tends to decide according to their commercial interests or about their budget for indemnification of responsibility. So, let us move to autonomous vehicles, because we find nice examples which are quite intuitive. Well, the first thing is that your research is quite important, because regarding a company decision, actually they didn't have to make a real decision about resignation, because we are only talking about, at the present level of the technology, test drivings where you have pilots testing pilots. So of course the machines are adjusted to transfer the control to the drivers when there is a problem, but with one criteria in mind: to avoid responsibility to the company.
Yeah.
Okay, and throw all the responsibility to the testing driver, and of course, for instance, take the case of Velasquez and the Uber accident. All the fault was taken on her, especially because the cameras showed that she was looking at an iPad or cell phone. But imagine, what would it be like if after 2 hours that a car is self-driving along a very boring avenue or road, then you are called into action 1 second before the accident, before the impact. So this is something to think about on the adequacy of the whole program, of the whole governance that was decided by the company. Was the company responsible within this criteria or not? And another thing that we should think about is not only the resignation. There are many criteria or elements that could define the moment of the resignation regarding, for instance, autonomous vehicles and any other application. I'll give an example using the Uber accident. And I will ask what a very objective, practical question. How were you going to settle if you were the designer of the Uber software? What happened was that, from what we have from the records, is that the vehicle identified something 6 seconds before the impact, but it didn't. It couldn't recognize that it was a person. It was an object, and it didn't activate the brakes. When it was 1.3 seconds before the impact, it recognized it as a person. And then it shifted the control to the pilot driver. And Velasquez had 1 second to try to avoid anything at all. On the other hand, so you see that what was the reason for this transfer? Of course, the company is aware that in 1 second, the driver couldn't do anything at all, but it shifted the responsibility, at least legally, to the pilot driver. And actually, she was there to be vigilant. Even though, if you consider she was human, it would not be easy to be vigilant at that point. So this is one thing, is to leave the decision to exactly to the point where there will be or there will not be, with a high degree of probability, an impact. Is this the moment to shift, to resign? But if you consider that 6 seconds earlier, the car identified something that, if you think very conservatively, there is something, I don't know what it is. Shouldn't I resign? Shouldn't the machine resign at that moment? Because there was a particular thing there. If you see the video, a human would probably not avoid the accident. It's quite fast when you can notice that there is something there. The machine would have avoided had the machine identified the obstacle as a human. But if they work together and 6 seconds after, the machine could make doubts about her capacity and say, well, there's something there, I don't know, I'll ask the human who is on board. So I think that there are different criteria. Would you put the resignation where there is uncertainty, or would you put the resignation at the point where there is a certainty that something's bad is going to happen?
You could do both, and I love that. That's the beauty of this kind of framework, right? Where it's like when we originally started building these things, it's kind of like, I don't know the answer as an AI system, and I don't want to take responsibility amongst many other reasons. So therefore, let me escalate. And it's kind of like this escalation procedure, which you're effectively turning into a governance mechanism, right? Where you're now like, okay, you know what? I'm going to just stop what I'm doing. I'm not really entirely confident. Let's kind of escalate accordingly. So the thing is, you can do it based on two ideas. And I like to think about it as two sides of a coin, because on one hand, you can do it based on how good the system is. So what you were talking about just now is that the system is not very good at identifying that. It might take another 5 seconds. So there's a lot of uncertainty in the system. So resignation might just be resign early in these settings, just to, and resignation here might actually just be flagging the object. And that might actually be enough. It doesn't even need to, you could still stay in autopilot. As soon as the wheel hits, you still give an extra 2 seconds, so you're fine. But it could actually be in the other case as well, where this is something that I enjoy doing. Like, for example, your favorite bend to drive on is coming up around the corner. Do you want to drive it today? You love going around this bend at 100 kilometers an hour. There's no one on the road. Go for it. Should we resign then? Maybe, actually, right? I enjoy doing that. That is something I get pleasure out of. So you're actually resigning in favor of something else, which is not outside the control of the system. It's not that the system can't do it. It's that we've been able to represent, and in cognitive science, we talked about this as like goal representation. I'm representing your goal, and I'm telling you that this is what I think you want. Do you want it? Or I can keep doing my thing. I'm not uncertain at the moment. Now, the issue is that in your setting where the human's bad and the machine is bad, you kind of really have to come up with something a little bit more clever. But the setting that you're discussing is, okay, well, the judgment is highly uncertain on the machine's part. Let's resign. The human is very good at this, and they enjoy doing this. So even if I'm good at it, maybe I should resign. And if I'm bad at it, it's even better, right? Because I'm bad at it and the human's good at it. That's an ideal task in some sense. Really, that discussion around them both being highly
uncertain is important. So one way of thinking about this is it's like high levels of occlusion when in driverless cars. I think a Tesla has like 8 cameras or something at the moment. If you wanted to make it stop working, I don't know how many you have to get rid of, but I'm pretty sure you can get rid of a few and then autopilot will stop working. So in that setting, what happens in terms of resignation, right? When the machine's bad and the human's bad, where now the windshield is unable and the cameras are not working. Okay, now
We resign it to God.
we resign it to God, and therefore, and I love that. I love it. it's in God's taking the wheel, Your Honor. God's taking the wheel. But I think these are important things to think about, and this casting and this kinds of like interdisciplinary discussions kind of help cast and reframe the problems in ways that kind of scale the way we talk about them.
Well, do you have any more questions? I have quite a few, but I'll be. I'm gentle. I'm a gentleman.
I thought about changing the subject a little from cars to our justice system. Not so interesting, but I mean, we all know that we have a system now, Atos, which is working on our Superior Court of Justice, which is an AI system that's supposed to select lawsuits that are alike and send them to the presidency of the Superior Court of Justice so that they can judge them all together as one issue. And then they resolve the issue, the legal issue, and all the cases are going to be decided accordingly. They think that's great, and I think that's already being used as a tool to admit appeals that come up to the Superior Court of Justice. But of course, it doesn't work perfectly well. And on the other hand, we have the problem that I told you about, that last year alone, 400,000 appeals arrived at the Superior Court of Justice, and we have like 33 justices working in the Superior Court of Justice. So we have like an inhumane amount of lawsuits to be judged and ruled. And we have now a system that is working in some level, but of course we have no guarantee that it's working well, and we don't have any means of regulating it yet, and we don't have any regulation yet. And I don't know, it seems that we are in a paradoxical situation. And I wanted to hear from you what you think of what you think we can do about such an issue.
Yeah, this is a tough one. This is a tough one. I'm not a legal expert, but that doesn't sound good. I guess that's my first reaction. I guess I'd say two things on this. One is, I don't know if that's the most efficient use of AI, to be honest, but I see how it could be potentially helpful. The real question is, in some sense, you can get down to a wonderful setting in which you define similar lawsuits as identical lawsuits. And if you have that, then you still need to litigate 400,000, right? And I think what ends up happening is we end up taking a maximalist take on these kinds of problems. See, the best case scenario, you're able to take the 400,000 and turn them into 5, and we litigate the 5, propagate the decisions back to the rest. Now, my argument would be start on the level of your if you define similarity in your AI system as identical, then there's no two cases that are identical. There's no nuance, there's still nuance. We're appreciating the nuance in every situation. So I can't propagate any decision. Every decision has to be individually made. And from there, you can start to relax this, right? Because there might be two similar incidents of jaywalking in a city. I'm not sure if that's illegal here, or 2 incidents of running a red light or something of that nature. I don't know what types of cases are in this court, but in some sense, the similarity in scope can slowly be defined. And generally, your errors in these systems will likely stem from your definition of similarity. I mean, in some sense, if the identical crime happened in 2 different areas, then the system is fine. It kind of works. But that never happens, I don't think. It might happen a few times. In 400,000, actually, it probably happens more than 5 or 6 times. But I see how the pressure can be put in place. One option is actually building a different style of system, which I don't know if it's in the works, of just like, how do we better aggregate the information that we have for these cases to represent the nuance in the set of decisions. So one of the things that one of my old students used to work on was, if I wanted to do inference on a group of individuals, one option is you get a decision on each of the individuals, but then I tell you how far away they are from that person who that decision actually applies for. And now it's like, well, you put uncertainty on it, and I'm like, okay, look, this might be right, but I'm this much, I'm unconfident by this particular amount. Right? Effectively, you're giving yourself slack. Now, the issue is that how can you give slack at the judicial level when you have to make decisions and you can't be uncertain in some sense? And I don't know the answer to that, but I would start thinking more about how we define similarity, think more about how we define and communicate the uncertainty we might have with the outcomes as some function of similarity, right? Because it's effectively saying that two things happen in two different areas. Like, even if I replace the people, the system is still similar, but I'm still confident in the decision for both cases. So it just from the way you've described that system, that's my initial reaction. But I imagine everybody else is well more versed, is very well versed in this.
Just a comment before moving to Renata, if she has some other question, is that the problem is that the similarity is approached in a way that involves no legal knowledge at all. It's not about, are these cases different or similar regarding some factors which are present in one case and are not present in the other, regarding the rules that are applicable. There is no reasoning about it. The systems that are applied to classify similarity of the texts, of the words that are used, and are the many tokens that are used within a sequence, a string of symbols. So it has nothing to do. And this is something again that should be clear, and it's not always clear, not only to the parties, the lawyers and the parties of a claim, but also to the judges, how it happens, because it is intuitive to think that the machine is comparing the cases, reasoning about the cases, but it's not. That's not what happens. It compares texts, and there is also there was a paper that was presented at the I think it was the ICAU 17. It was in the I think at King's College, and the paper proposed to compare, to detect when two judges of the Court of Appeals in the United States would disagree. And the hypothesis, the main hypothesis was that they would disagree regarding their profiles as a progressist or a conservative, etc. So the text, the title of the text was "The Genealogy of Ideology," and the system worked with a degree of accuracy of around 75-80%. But the elements, the factors which were more, what are driving the decision about agreement or disagreement, or in the first place, the place where the judge sat on the court. The second one, the extension of the text of their opinion, and the third one, the number of citations, of quotations. So nothing to do with legal knowledge. And I have other questions, but I'll give the room for Renata.
Taking from your comments, we see that in these cases, we want to imagine that there's some reasoning going on. And that's something also I was thinking, if you are planning to restrict things and say when the algorithm should resign or should not and give access, how are we giving these rules? Are we giving it this in a symbolic way? Because I think the key now, and everybody's working in neurosymbolic AI and trying to combine things. So all the gain that came with machine learning and deep learning, combine it with things, expert knowledge. So things that we used to have in the first expert systems and had these rules and previous knowledge. So as this example that Juliano mentioned, so when you just leave the system, find the patterns, sometimes some very weird things come out of it. And maybe someone should say what similar means and give a list of factors that should be taken into account. So do you see this happening?
Yeah. And then we should, Renata, call to the team of designers some philosophers, no? to ask what similarity means.
Yeah, we can always discuss, but yeah, it's impossible. And you can only think about similarity and give some definition if you take a very specific domain. So you say, or at least use the classifier to give you some aspects, maybe give you some extra data in some organized form, but not. Yeah, you need to have knowledge, previous knowledge infused into these systems so that they don't just do something random.
Learn how to write,
Yeah.
because since the system is comparing texts,
I think
you compare a bad petition with a good one, and then you have like one case explained really well where you can get the arguments well and the other not. So
I think if there is a way of codifying nuance on paper via a philosopher, whoever does it, honestly, I don't really mind who does it. That would be ideal. But in the case we can't do that, I think one of the things that's, to take a techno-optimist perspective for the sake of argument, it ends up becoming very interesting when even when we do include that kind of legal knowledge, we still might end up using the number of citations to make decisions. Because that is somehow, for some god-awful reason, the best indicator for how judges rule. And it's like, in one of the classes I teach, we think about it as, do we want the systems we develop to be a mirror of the society we live in, or to mirror society the way we want to live in, right? What kind of society do we want to live in? I don't know, but I have an opinion. You have an opinion, and it's probably somewhat similar, but not entirely similar. So the current agreement is, let's just take our horrible society and just project it back as is, which is judges look at the number of citations, and basically the council that puts in the most work in terms of getting the most citations from their clerks gets the victory. And that's that, which is a horrible system. And I hope we can find ways to mitigate that. And I think there's interesting fairness questions that come up actually in this discussions. When we were talking about responsibility earlier, it's you end up disproportionately impacting certain groups of people. And I think different definitions of fairness at the moment are quite Western centric, and they kind of talk really explicitly about protected attributes and protected groups. And I don't know and don't necessarily think that that's how everybody thinks about it. So just because that's what's been codified in law in America and in the United Kingdom, that doesn't necessarily apply everywhere. I had given a talk in Ghana earlier this year, and people were like, what are you talking about when you're talking about these definitions? It doesn't necessarily resonate. But yeah, this has been a wonderful discussion. Lots to think about resignation and regulation, which is exciting.
Well, we already getting close to the time we settled to finish our roundtable. But we started a little bit later, so I think we may have some more minutes. And I want to hire you again, Umang, to my vehicles company as a designer of resignation of the machine. So let me come back to the example of autonomous vehicles. So it's easy between should we resign when we are certain that something bad is going to happen, or should we resign when the machine doesn't know exactly? When it's a testing context, we would answer when we know that something wrong is going to happen, because then we shift the responsibility to the driver and we save the pockets of the company. When it and also uncertainty is a good thing in a testing environment, because we want to learn more about the machine. So, but the thing is going to shift completely when when the car is going to be deployed and sold to consumers, because then, according to the legal perspective, the employee who is a testing pilot and is there responsible for being vigilant, he should be able to take quickly action. But when it's a passenger to a driverless car, it's different. The company would have no argument to say, well, 1 second before the impact, we resigned the machine and the passenger took over. Well, but he was there to just enjoy the trip, not to be vigilant. So it will be a completely different situation to decide. So maybe you will be closer to saying that when there is uncertainty, let us ask the passenger. I don't know. This is the first question, and later I have another one.
Yeah, no. This is a good one. So, and then maybe we can ask if anybody here has questions. We can also discuss them. But
yes,
yeah,
sorry.
after. But so this is an awesome question, because from my understanding, what you're arguing for is something that is a natural concern. I can, in test beds in simulation, resign and communicate that I am uncertain. However, it is in my best interest that when I'm certain that something is going to go wrong, that I also resign in some sense. And the issue is that with that knowledge, you can actually start to build systems that will display uncertainty in those settings. So you'll be able to legally get away with it effectively, which is actually quite interesting, because the measurement of uncertainty, because it's a measurable quantity, it can be manipulated. So we talk about this idea in computer science around this notion of calibration. We always talk about calibrating models correctly. What does that mean? That means that when I'm certain, I'm going to be correct in my prediction, and when I'm uncertain, I'm going to be likely less correct. It can still be correct, but likely less correct. The interesting thing is that this can be miscalibrated. So you can go and start to manipulate these kinds of measures to then say, you know what, like, I don't want to take responsibility for these kinds of things. That's an interesting question. I want to flag that manipulation is possible, because that is something, as a computer scientist, that I can communicate to a room of lawyers to say that might not be on everybody's radar, that that kind of work is possible. But I think that one option is actually still resigning in the setting where you're certain something bad is going to happen, and then chalking it up to the fact that the terms and conditions you had the passenger and the individuals agree upon when they entered the vehicle was sufficient for arguing that I'm going to resign in those settings. Just thinking from a company's perspective, not necessarily in the best interest of the populace.
You are an evil mind. I thought only the lawyers.
I'm just saying the lawyers. Look, we have a lot more in common, clearly.
And it's interesting that you came exactly to the point that I would like to question. It is about calibration. What if, later I will explain, but the question is, what if you delegate the calibration to the final user? So I'll refer to a paper regarding the moral machine problem. There was a paper by a team of computer scientists and lawyers at the University of Bologna, and they proposed it was a knot. You have in the car, you imagine you have a knot where you can adjust whether you are selfish, or whether you are solidary. So you could, regarding the moral machine problem, should the car sacrifice the passenger, or should the car sacrifice the pedestrians? So you could use the knot and say, well, whoever every time favor myself, or favor the other. But it could be a degree. Well, 80% favor myself in 70%. And you show the spectrum there, from being over-trust to being distrustful. So what if the company leaves this decision to the consumer? I can buy a driverless car, and then as a user, I just adjust. Well, I want to be more distrustful or otherwise, and then you shift the adjustment. This will shift the whole game of responsibility.
So there's two interesting points there. This is an excellent fun topic, because there are two, and this is the big reason why actually I started working with cognitive scientists, because I don't understand how people think, because people are really irrational, and we need to explain that in some way. So there's two interesting points to make. And the first is, if we leave it up to the individual, one of the things that we already kind of know is people are really, really bad at understanding numbers. Their numerics, as we call it, or numeric ability is very low. So on average, people are unable to interpret fractions even in sensible ways. So it actually, again, works in the company's best interest to communicate these kinds of things in this way, which in some sense is counterintuitive to the types of arguments I think you're trying to make, which are just like, oh, well, we can over-inundate you and you won't be able to tell the difference between 75% and 79%, but that could mean all the difference, right? I mean, in some sense. So I think the vehicle by which you create that knob is like the most important thing. How do you actually communicate this to an individual? That what does it mean if I say 25% of the time you have to take control of the wheel? What does that mean in practice? So maybe one way of communicating that is, during the month, I have to spend roughly 1 week driving. That's roughly what that means, 25% of the time. So it comes down to the way in which you present the information and the way in which you ask the information. And the issue is that you find that with this small change and that kind of presentation, I can get drastically different results. The other thing that I think plays a role in this notion of calibration is not only the way in which you ask it matters, but I think people are just really bad at perceiving how good they are at certain things. So again, maybe that bend that I love driving around is also one of the deadliest bends, right? So maybe this is the one bend, the one turn that I actually need to leave up to driverless cars. And I think in these kinds of settings where you misperceive your abilities, where I barely understand numbers, this is when I start to get very nervous about giving these things back to users. And it's like the promise of AI kind of disappears if I'm able to do a good job at the term with high certainty. That's a very, very strong statement right there. If I'm able to make that turn with high certainty with an AI system, but someone perceives that they're able to do better than me, and we know they're not, we provably know that 50% of people going over 100 kilometers around this turn get into an accident. That's why we put speed limits in place. Well, maybe we don't let this person drive there. So it's weird. Like you have to calibrate not only like, it's have to be calibrate, but also be sensible. So, and sometimes I feel that their irrationality of some decision makers in their perception of themselves, or just the way in which you present something. Like there's so many studies in CogSci these days where it's like the background is blue versus pink. So people respond differently. If it's sunny outside or rainy, I think there's someone who'd done a study with judges and judges' decision making. Was it rainy? What did they have for lunch that day? Was it before or after lunch? All else constant with respect to similar, which I know we weren't able to define. The outcomes vary. Like these are kinds of things that remind me that we need to try to build AI systems. But all at the same time, I understand what you're saying, where like ideally, if you left that up to a judge, you would get a very different situation because they would perceive, well, I've never made a mistake in this situation. Well, sir, you've only approved 25% of cases or passed 25% of cases in favor of the prosecution after lunch.
that is like a drastic difference from what you might have before lunch. So it's an interesting human fallibility question as well, which I think we forget in the AI community because we care about building the best model, building the best driverless car, building the best something that automates. What you've described to me today is it's kind of absurd. I'm thinking about it more that you've automated this idea of like there's just too many cases. Like we just got to get some of them automated out of the door. Like that is an absurd thing to say. Like, but I can see why that's like the rationale that was used there, but the fallibility that happens at the decision making level. So like the initial reaction, for example, is actually having you make little clusters, and if you guys know people who work on this, we can totally start thinking about this, but you make clusters of, let's say, groups of 10. You randomly sample 3 cases that are similar. You judge all 3 and then take the average decision of all 3 from 3 different judges and then propagate that back. And you can probably show very quickly that your decision-making quality will improve. So you get a 30% reduction as opposed to a 90% reduction in case volume. But the idea is that you like double and triple check. So we have done some work in the past, and other groups have done even better work where you take images of like different animals and you have humans label them. And if you have 50 humans label them, some of them will just have completely different perceptions. So, I mean, yeah, maybe I took a picture of a bird, but someone actually perceives that to be a plane. Like, okay, like that's a perception question. So we can find differences in judgment. And I think with some of the things that you guys have been describing, one of the ways you can do a better job of describing similarity and basically propagating the right decision back is getting uncertainty at decision level. Because right now you're getting it from one person and one person is likely to be biased, but 4 or 5 estimates of it should be good, right? Of random cases in that cluster, label that whole cluster with that, and then propagate it back. We can chat about that. It's just an initial reaction to that point.
Okay, I will then now ask if somebody in the audience will have some question or some comment. It's better to use the mic.
Thank you. So I wanted to zoom out a little bit on the conversation that you guys are having. It was very focused around lawyers and engineers and computer scientists, right? Now, all of that is assuming there's a constant in the policy, right, that governments are putting on AI systems. And a lot of policy tends to work bottom up, where incidents happen and it's very reactionary. But the conversations you're having today are very proactive in a way, right? You can kind of use some of these incidents to turn the tide there. So is there a way where we can work together to push policy forward in a more proactive way? Like how could you see these conversations happening with more public officials?
Well, I mean, I don't know in the Brazilian context, but I think that this is the point of these kinds of discussions. In some sense, the city of Sao Paulo, City Hall is represented here in the room. We'll have lots of discussions and write some legislation together and get it passed pretty quickly.
Yeah.
But no. I mean, I think you guys might be better equipped to answer it in the Brazilian context.
Yeah, actually, we are making a hypothesis and trying to guess and to actually evaluate what are the risks that could be dealt with, both technically and also legally, because the rules have these dissuasive or they make incentives for conducts, but you also may, which is interesting, is to make it by design within the machines. And actually, you're right that it's much better to regulate when you have already and go from bottom up. You go from the experience of a lot of conflicts of cases or different situations to design a rule, because you have already, even if you have court decisions, then you can learn from an experience, from a state of art. But we don't have it at hand with artificial intelligence. That's the problem. We indeed have a project in the Logarithm Institute called future precedents, and where we have invented 15 cases of conflict involving artificial intelligence, and we are going to ask real judges to decide it, just to say, well, as if we would have precedents that will happen in the future. So this is something that we can do to try to anticipate. How would judges respond to this kind of case? Will they have the necessary tools with the present legislation, or should we have other rulings, or should we have other rules? The problem is that things are going so fast that we have to hypothesize and try to anticipate and avoid risks and problems.
It's always the challenge with law, because we always regulate too late. First, we have to know what the problems are, and then we come up with a rule to regulate what happened and what we already identified as problems. So that's inevitable. I think that happens in all areas of law. That's just another one. But it's like you said, it's happening too fast. It's affecting all areas of life. And we have a bill at the moment being analyzed by the Congress on regulating AI. But obviously we can't foresee all the questions and all the risks that are at stake. So it's very hard to regulate, especially when we have people who don't understand how technically AI works in practice and how it can be applied in all areas of life. So it's a very complex problem. I don't know.
Would like to add something?
I couldn't hear. I was wondering whether there's. Okay, I see a chat here. I was wondering whether there were questions from the audience. I'm worried that we are taking all the time here.
I've asked it, but it's until now no one raised a hand. Just our friend. Here,
Okay.
I forgot your name.
Hirsch.
Hirsch.
Any others?
Then we can.
Right in the back.
Hi, how are you doing? My question has to do related to the topic that I written while I was in the US. I did my LLM at and my paper was on constitutional law. I teach constitutional law, international law. My area of expertise is constitutional international law, also legal English. And I wrote about the Kurumatsu versus United States case. I don't know if you know about that case. For people who are not from the US, that was the case that there was an executive order. An executive order would be like a decreto presidencial by then President Franklin Delano Roosevelt that sent all Japanese American to detention camps during World War II, regardless of their culpability, regardless of their then being accused of something only based on their racial stereotype. And my concern regarding AI specifically is that AI is based on mathematics. You know, the founder of AI was a mathematician, which was Alan Turing, right? We probably all saw that movie, The Imitation Game. You know? And AI is based on algorithms. So how can you use AI in a meaningful way in the judiciary, but avoid phenomena as racial profiling? I think that's something that's concerning of AI, you know, committing injustices because they may be matched in a certain way that will create wrongful algorithms. Thank you.
Yeah, that's a really good question. I'll quickly jump in, but I'm thinking about racial profiling and fairness questions as it pertains to AI. I think it comes down to one of the things I was mentioning earlier, which is that if we decided to look at every person that has been arrested in America since America's inception, we will end up with a bleak picture of people to put behind bars. So if I'm trying to predict the odds of someone going behind jail, your Black Americans are going to be much more likely, because I might include data from my Jim Crow era and basically from even before, and you're going to end up with a bleak understanding of how the system works. So the real question goes back to what Renata had mentioned, like, whose value judgment is it going to be for us to exclude that kind of information? And if we choose to exclude that kind of information, what should we optimize for? Because all that AI systems do, exactly as you mentioned, there are math problems that we set up for ourselves. We observe things in the world. So ChatGPT's observed all the natural language we've all written, or we've observed a specific set of racial, or observed our arrest records basically in our country, and then said, okay, here's the likelihood that this person will be arrested or should be arrested or will commit a crime. Depends on what you're optimizing for. But it might not represent reality today. And the unclear thing that's not entirely resolved at the moment is it's not clear whose benefit or whose judgment should be at play. I'm sure you guys have thoughts on this.
Oh, I think that first, we cannot say that, well, artificial intelligence is about computer system. Computer systems are based on mathematics. Actually, computer systems are logical machines, and so they are completely incompatible with what lawyers or judges do, because there are many aspects of legal reasoning which are based on reason and on logic, and there are many aspects that can be represented and modeled, not only about reasoning, legal reasoning, but also about aspects of pattern recognition that are present in an analysis of a case. So we shouldn't see at first and from the start as something completely incompatible. And the second point is, we are not always, and actually very rarely in the present state of the art, talking about substituting a judge for a machine. So it is about finding aspects of the judicial activity that are repetitive, that could be by machines, leaving the judge or her staff with more time and energy for creative aspects or for exercising their domain knowledge. As I said, these the aggregation by similarity helps a lot the job in a cabinet of the judge, but it doesn't substitute the activity of the judge. It's a tool, and it's under his scrutiny and control. What is important is to have, and there are methods of governance that are largely discussed to avoid risks for the delegation of these particular activities.
Professor, just make a quick comment here. I think that's in the ideal world, I would agree with you, but if you see the reality, for instance, of the Brazilian judiciary, which judges more cases more times than many other countries, for you to have an idea, Professor Bhatt, no? Right, Bhatt? Brazil, the Brazilian Supreme Court hears judges, I think, 10,000 cases a year or something like that, while the U.S. Supreme Court judges 200 cases. And there are studies that show that it's humanly impossible for a Supreme Court justice to judge as many cases. Even if the guy only had lunch and worked all day, which they don't, of course. They give lectures, they give classes, they speak about themselves, they travel, they have so many activities that I find it amazing how they find the time to judge, They wouldn't be able to judge all that. So, of course, that in reality, much cases that are heard, trialed in Brazil, are done by law clerks. São os assistentes judiciais. I teach legal English, so I like this term, like law clerks. So if they use law clerks many times, wouldn't they just throw everything into AI for assistance without the necessary back checks? I found that concerning.
Well, actually, I see this problem as an argument for using those tools, not against using those tools. What is important is to have actually and to take and use best practice to mitigate risks, which of course are present. And the risks which are present here in Brazil are different from the US regarding those particularities. So, so there are many aspects that are used to try to mitigate, which cannot be eliminated, for instance, about discrimination. But there are methods on regarding the development or the deployment of this system. There are technical methods. Umang just brought a proposal and brings the research trying to find a method where you incorporate responsible AI within a technical system. But you also have organizational methods. And what is important, I think, is, are the risks present? Yes. So should we avoid using these tools? You are going to avoid and to abandon many benefits that could be achieved. So I think that the best reply is to try to map what are these risks, what are the problems, and let us use the best practices to try to mitigate these risks with methods of organizational governance and with also technical governance, as Umang proposes.
I wanted just to comment on what you said, Juliano, about computers being logical and mathematical and things like that. That part of computing, so rules and logic, is much closer to law than what's happening in deep learning and machine learning in general. And as Umang mentioned, the problem is that so the machine learning tools, they are trained on past cases. So if you take the problem of prisons in the US or even here, you have this case of racism being propagated. So this is the case. If you're using past data to train, you are tending to propagate all the biases, and this is very much discussed in AI. And if you want to avoid this, you need either good data or you need to be able to add rules. And in this point, we get to the logic machine and the computer being a logical thing. But not with just pattern recognition.
And I think we come back to what Umang said before. Are we proposing the world where we live or the world where we want to live, right? Are we going to create rules of the world as it is or as it should be regarding biases or all the rest?
Exactly. We have to think about it when we are trying. So one thing is driving a car, another thing is judging people. It's very different, I think. Yeah.
Well, we are already ahead of time, so I would like again to thank and to ask for an applause to Umang Bhatt. Thank you very much for coming. And would like to use this last 2 or 5 minutes to talk about this book that has just been published. We have some volumes here that everybody who came presentially to this event is going to receive one copy. So this is just to make and to create some envy to those who are only online. Renata, you have yours, okay? Don't worry. But actually, this book is about, we saw this year the explosion, the popularity of generative AI. And this book gathers many texts that were written by researchers of the Legal Grounds Institute, commenting many legal aspects or interfaces of the generative AI systems with the law. Not only the impact on the market of the generative AI and what is going to be the reflex regarding competition in this market, and there are the law, the competition law, to handle the problems that are already appearing. Questions regarding copyright and many other reflexes that impacts on the legal profession, which are of course, it's a concern not only for lawyers but also for judges, and many other interfaces with generative AI and law. And we have gathered those texts that were written in newspapers, in specialized journals, which then I think it's a nice introduction to get to some interesting problems. I have the text, usually don't bring definitive answers, but raise interesting questions for the readers to reflect upon. Okay, so you are all very invited to get your copy of the book, and later we can also do some networking and discuss actually in the coffee break, and then actually eating something, drinking something, because we're already a little bit tired. Thank you very much, Umang. And see you then next year in this committee. Please pay attention to our program, and also would you like to make the invitation for those to apply to be a member of the committee?
Sure. Everybody's welcome to join the committee, and just send us a message or an email to IASP saying that you want to join the Committee for Artificial Intelligence, and we're going to start working next year as soon as possible on new events.
Okay. What's the email? The email to send?
Yeah.
Contact them per WhatsApp, so just a second. You can send to raquel.souza@iasp.org.br.
With an S or a Z?
Souza com S, com Z. Mas pega um cartãozinho aqui na frente.
Mm-hmm. Okay, so thank you very much. It was
thank you for
really
having
nice.
me. This is really lovely. Thanks for all the wonderful questions. This has just been a surreal experience, just talking about these things and getting great feedback. So thank you. Looking forward to connecting with you guys. Cheers.
Thank you.
No.